Okay, we're going to do our last section today. In the next 2 weeks, we're going to review. So today we're going to finish up with radicals. And let's just start with one here where if we have these side by side, you have a dot here, and we are multiplying them. Let's go ahead and multiply them. If they're whatever side you can multiply, so we would get radical 18. But then we don't leave it as radical 18. Remember, we look for any of these numbers, or any of these that could possibly go into here. So is there a number over in this column that could go into 18? 9. So we can break it down into 9 times 2. Square root of 9 is 3. 3 radical 2. So how we're going to see more of those, we'll have both a least coefficient and a radical. So the numbers out in front we multiply, and then the numbers inside we multiply. So 2 times 18 gets us 36. Radical 36 is 6. So we have 12 next to it. 12 times 6 would be 72. Let's do one more like that. Now I'll change that. Okay, so we have 4 radical 10 times 3 radical 15. We're going to multiply 4 times 3 is 12. Inside we get 150. 25 will go into 156 times. Square root of 25 is 5. Radical 6 does not simplify anymore, so we get 12 times 5 is 60. Radical 6. So now we can make those, we can't think of, they will make them even more involved and complex by making fractions. So we could only make it one radical, we could make it several radicals. That part really doesn't matter as long as you realize if it's in the radical, we're multiplying. We could multiply first and then simplify, or we could simplify and then multiply. It's going to be easier if we simplify first by going diagonally. For instance, 7 could go into both 7 and 14, so 7 will go in once, 7 will go in twice here. Now we look at these. What could go into both 3 and 21? 3, so 3 will go in once, 3 will go in here 7 times. Now we can go ahead and multiply. We get 2 sevenths. So we get radical 2 over 7. Correct. I copied it wrong. I copied it wrong. Okay, we gotta go back. That was 3, this was 27. So now, what could go both into 3 and 27? 3 go in here 9 times, so we get 2 over 9. 2 does not simplify, but radical 9 would become 3. Okay. So basically on division ones, we want to simplify as much as possible from the start. All right, let's do one more of those then. Four over 9, 18 over 4. So on this one, will anything cancel to start with? 9 will go into 18 twice, the 4s will cancel, so we're left with radical 2. If we let's multiply the whole thing out. 2 times 1 is 1, 2, 1 times 1, so we're left with radical 2. All right. So if you take your time and cancel bit by bit, they're not overly difficult. All right, so let's do one more variables. So this one, if we go ahead and multiply, let's change these. 2x times 6x If we multiply them out, we get 12x squared. So we can break that 12 down into 4 and 3, and we also have x squared. So let's start with 4. What would that give us? 2. 3 does not break down. X squared. What do we do with our power? Do you remember? Divide it by 2. So x divided by 2 is x to the first, or just x. Let's do one more with a variable. One more. Bulb. We put parentheses mainly to show you this negative is here and that you're still multiplying. Okay, so the two coefficients out in front are 5 and -2. So multiply them, we get -10. Now in our parentheses, we have m times m gets us m squared, and we have n squared. This stays out in front, we're done with it. Square root of m squared, m, square root of n squared, n, nothing left inside. So there's our answer. So let's do on page 538, 39. Uh, 13 to 39 odd. 13 to 39 odd, 538, 539.